tous les participants sont en mode écoute seule.
Good afternoon, everybody. We are very pleased to welcome you to Gateone-project webinar. As you know, this webinar is dedicated to answer to the question, is smart agriculture a promising market for European companies? So I'm Géraldine André-Augustin, the CEO of Blue-Morpho, and I'm very happy to be the moderator of this webinar today. As you know, this webinar is designed to be very interactive. We are very pleased also to have key experts with us today, coming from FAO, coming from ITK, and from the Gateone-project, as you can see on this slide, and I will introduce them to you in a few seconds. But before, as you know, it's an interactive webinar, so you can ask directly your questions during the webinar. You just have to go to this box here, the chat box, and enter your questions. And during the webinar, we will ask our experts to answer the questions, but it will be read at the end, of course, of the presentations. So here's Smart Agriculture Bankable Challenge. Just for you to know, at Blue-Morpho, we are defining bankable challenge when a challenge fulfills the following parameters. Do we see a validate market pull demand? Do we see an economic challenge for which we need this challenge to become a reality? And does a solution exist to address those needs? If not, that's also a very interesting challenge to face. And did we identify acquirers and investors for this solution? We consider that smart agriculture could definitely be a bankable challenge, but it has to be confirmed. And that's why we have this webinar today. So to answer those questions, we are very pleased to welcome our guests. And our guest is first Nevana Alexandros Stevanova. Good afternoon, Nevana.
Good afternoon, ladies and gentlemen. It's a definite pleasure to be with you today. I'm Agricultural Innovation Systems and Knowledge Sharing Officer of the United Nations Food and Agricultural Organization of the United Nations. And I work actually for the Regional Office for Europe and Central Asia, which is based in Budapest. My organization's headquarters are in Rome, as you may know.
Thank you.
I was asked by the...
Yeah, sorry, Nevada. In just a few minutes, we will give you the floor to make a more detailed presentation about your activity.
Thank you.
Okay, and thank you very much to be here with us today. We are very, very honored to have FAO with us today. I'm also welcoming Eric Jalas from ITK. Eric, do you want just to give a few, so ITK develops decision-making tools in production agriculture and allied industries. Thank you very much to be with us today as well. We are very interested to know more about your company and your point of view on smart agriculture.
Thank you. Hello?
Yeah.
Yes, so hello to everybody, and Geraldine, thank you very much for inviting me to this seminar, to this webinar.
Thank you very much. And I'm welcoming our host, Régis Hamelin, the CTO of Blue-Morpho and also scientific coordinator of the Gateone-project.
Good afternoon, everyone.
So, smart agriculture bankable challenge. Why we are raising this question is because we have identified with the FAO analysis that the world population will raise to 9.6 billion by 2050, that the food production must increase by 70% by constant land area to face this challenge. So how do we do that? And there is a need for fresh water of the agricultural sector because it will increase drastically. It's important to know that agriculture consumes about 70% of the world's freshwater supply. And as we all know about that as well, the climate is changing and it has an impact on seasonal events, and it has an impact on the life cycle of plants and animals. So the challenge is here. Now the questions we are addressing is it a bankable challenge? So I'd like to first give the floor to Nevana Alexandros Stevanova, so she can also introduce FAO and give a point of view on the importance of smart agriculture. Nirvana, the floor is yours.
Okay, good afternoon again. The organizer invited me to talk to e-agriculture at FAO, and I'm going to provide you with the notion of what it is in our terms and what is the concept behind. But first, I would like to start from the introduction with a statement that the world is facing unprecedented challenges in access to resources and energy, and it is aggravated by the climate change effects and other natural and human-borne disasters. The situation is so dramatic and so unpredictable that we have to understand that agriculture is going to change very dramatically in the next years. This situation definitely calls for humanity to utilize all available technologies and continue to innovate. When I'm saying all available technologies, I mean definitely information and communication technologies, but also biotechnology and agroecology. And this has been recently highlighted by our Director General, who actually reflected the wish of the member countries of FAO. However, we are going to talk to information and communication technologies that really have large potential to leverage agricultural sector if it's properly focused. However, we have to understand that if you can go back to the slide, please, we have to understand that those innovations, they have to be solution-oriented, demand-driven, and technologies alone are not going to solve the problem per se. What we need to do is to scale up the innovation, and this can be done only if strategies and markets and legislation are developed. So next slide, please. If I can have the next slide.
Yeah, it's coming. Sorry about this. Here we go.
So the e-agriculture refers is an emerging field that is focusing on enhancement of agricultural and rural development through improved information and communication technologies and processes. And in this context, in e-agriculture concept, we encompass all technologies that are more innovative, that you may call smart, or those technologies that are not so smart but do have an impact and proven impact on farmers so far in the developing world, like radio, for instance, all range of sensors, internet and broadcast, mobile phones, etc. And next slide, please. And FAO is working for a long time on raising the capacities of farmers and also governments to use information and communication technologies. We have developed different standards, different e-learning courses translated to all UN languages and also some national languages that are non-UN. We produce good practices, good practices models and databases to capitalize on existing experiences. And since 2006, we also operate the e-agriculture community of practice, which I definitely recommend you to join. These are practitioners sharing different issues and experiences. But I would like to talk more about the region that I'm working in. This is the region of Europe and Central Asia. And I would like to tell you about this guideline that we developed, a guide on e-agriculture strategy development. So we thought that we cannot go further if the governments have no strategic view, no vision, how far they would like to go with the use of information and communication technologies. This implies, of course, infrastructure issues, capacity development issues, but without creating an enabling environment, a comprehensive one that includes also vision about subsidizing some sectors of priority, of prioritizing the chance of developing work would benefit from ICTs without creating more problems is not so good. So what we did last year was we developed a guide and we made a conference in the region of Europe and Central Asia. Why in Europe and Central Asia? The fact is that, you know, agriculture is a field that badly needs innovation. However, agriculture sector traditionally lags behind in adopting, generating innovation. And in Europe, actually Europe lags behind other regions in doing so, because one of the solutions is because so far strategies and priorities of government were not so targeted.
Okay.
What we would like to do with this series of events that we perform actually every year is to sensitize governments that they have to develop those strategies. And the strategies, why strategies? Because they can develop, avoid duplication of efforts and resources, develop efficiency gains from intra-sector and cross-sector synergies, and equally consider better use of data and merging the digital divide for smallholders and family farmers, men and women.
So it means
You
that
can go ahead.
On your side, you think that smart agriculture has to be part of this strategy for developed agriculture in the different regions in Europe.
Yes. So my key messages to your audience, if I may, are the following. We have to take into consideration that not all technological solutions are innovations, because innovations are those solutions, processes, the practices, the products that have already an economic, have been put into practice and have economic benefits for farmers. And it's a long road from ideas, from research and designing a prototype until you do commercialization and you gain acceptance of your customers. You for sure know that. But what will be the solution? And that's my next key message. It's that the farmers needs and their capacities are at the core of solving this problem. And no solution that is developed without close cooperation with the farmer who is going to use it can be sustainable. In this sense, small and medium-sized enterprises would be better positioned in the market than some other, the bigger companies. This was a conclusion that we had in our last workshop 2 weeks ago.
So you think that
And
SMEs, you think that SMEs are really a role to play here in smart agriculture? Is your message?
Provided that they cooperate with farmers and they work closely to the field.
Okay.
And they also flexible to do that. So acceptance and access issues are key, and if they are not resolved, we're going to have a bigger digital divide instead of divergency of people, poor and rich people, and farmers, big farmers, small farmers, gender, that is facing triple divide because of more constraints in the developing world.
Okay.
And prioritizing e-agriculture at country level is absolutely must. That refers to resources, responsibilities, capacity development, very important, and delivery systems. These are advisory services in agriculture that at the moment in no country in Europe are able to promote information and communication technologies, any kind, not to talk to precision agriculture, except they are highly specialized private advisory. And the solution that FAO REU is offering is the agriculture strategy guide. And we do collaborate with several countries already in Europe. And we are helping them to build their national strategies. And we are looking for partners. As you may know, FAO is a technical organization. It's not a bank. It's not a donor organization. But we are trying to identify donors to work with. Unfortunately, in European Union, it's only one country that is flagging smart agriculture as a priority, and it's Belgium.
It's Belgium that has agriculture as the priority country?
I didn't quite hear you well.
I'm really sorry because we are very happy to have you, and we really recognize that it's difficult for you because you don't have the right situation for you. You are currently traveling, so it's difficult. But we are really thankful that you are participating to the webinar to share this important point that e-agriculture has to be a priority at country level, and this is something that to be further developed in Europe. This is your point.
Yes.
Thank you very much,
Thank
Nevada.
you.
It's really very interesting information for us because we wanted to make sure that there is a need and there is also a kind of political strategy behind smart agriculture. So thank you very much, Nevada. We will go on by reviewing also what are the trends in this market, what the solutions that already exist and are in development. And if you have questions for Nevada, please send us on the chat box and we will answer to you separately. Thank you very much, Nevada.
Thank you.
So after this presentation by Nevada, I'm sorry for all the participants because the condition was not so good in terms of surrounding noise, but we wanted to really to have the point of view from FAO, and we hope that it was interesting to you. Now we would like to also to raise different questions that we have received by organizing this webinar. And those questions are, we will drive this market, what are developing countries and how they are developing those challenges regarding smart agriculture. So we have a lot of different questions that I'd like to ask to one of the experts, who is Eric Jalas. So thank you again, Eric, to be with us. You are the CEO of ITK, and maybe you can introduce us very briefly your company.
Yes, thank you, Geraldine. Yes, but I believe the beginning of my presentation will start to answer your question, or the title of this webinar. Is smart agriculture a promising market for European SMEs? So ITK is an European SMEs. I launched a company 13 years ago, And now there is 55 permanent employees, 25 are PhD people, 26 are have a master degree. We have 2 patents, and we are working with, I will say, with a leader, with world leaders in Syngenta, Crop Science, for example, Winfield, which is a subsidiary of Rondolex, which is the second ag crop in the US, and now we are also working with Verizon, which is a 41 company in the world. Okay, the core competencies of ITK are crop modeling and decision support system for agriculture.
So yes, I like to ask you the questions then. You are a very interesting company, you're working with big players, you are yourself an SME, European SME. So according to you, who will drive these markets? And also we speak about this growing of population, this need for more food production. This growth of population is coming from developing countries, and how do they face this smart agriculture challenge?
Okay. So who will drive this market? Could you show perhaps the next slide? Could be interesting. On my presentation. I have the control?
Yes,
okay.
The control.
So the ITK domain is precision agriculture. Up to now, in fact, the market has been driven by equipment. If you look at this graph, you can see, in fact, looking at the US ag supplier providing precision ag service, mainly the main ag services that they are providing today could be field mapping, satellite aerial images. That's the 2 main. You have soil electrical conductivity map on chlorophyll and some sensor. So as you can see, in fact, the market has been really driven mainly by equipment on precision cropping equipment. Okay, so it's working the next. So the next step will be to provide to this market intelligence tool to analyze, in fact, the data that this type of equipment are collecting, but also the data that we can get from different providers as weather, for example, weather data, but also all the cultural practices that the grower is experiencing or is using, and through this data, try to elaborate new recommendations. Okay, why? In fact, we need to elaborate new recommendation. If you look at, I don't know if we have this slide, but if you look at the current situation, the system has been also driven by genetics. Monsanto, which is one of the most profitable company in the ag business, is mainly selling, in fact, gene. But as you can see, in 2013, Monsanto bought Climate Corp for close to $1 billion. On why? It's because now the expert knows that the production increase, the ag production increase will not come from genetics, because today, if you look at, for example, the genetics, the yield increase linked to genetics, now it's lower than 1% a year, even by using GMO. The GMO didn't increase, in fact, the yield production, okay, as it was expected. Perhaps GMO reduce the use of some pesticide or some herbicide and so on, but they didn't increase. So we know that the production increase will not come from genetics, as it was expected before, and will not come also from new chemicals, because you have less pattern every year, and it's much more complex. For example, EU tried to ban 50% of all the active ingredients that are used today in EU. So the increase in yield will come in production, will come, in fact, from new solution or new cultural practices that the grower will implement, in fact. And you have to remember that the grower is the best ag expert in fact, for ag production. So it's also the reason on your second question that you raise, how are developing countries addressing those challenges? Okay, that means if we want to be sure that this challenge will be addressed in a developing country, the grower has to be really in the middle of the process. So for example, on ITK, we have a subsidiary company called Itumba. Through new technologies, they are providing directly new information to the growers that the grower can implement his own knowledge and his own expertise through this information that the grower is receiving only on his mobile phone. So you don't need, for example, necessary big, I will say, computer, laptop and so on. Just with a simple cellular phone, you can provide directly to the grower a piece of information that will help the grower really to better manage. And it's so this idea to have the grower really in the center of this question is the tools that we have to develop as to help him to see, for example, above, to see further. That means to see, for example, what will happen tomorrow if I'm doing that, and also to see closer to what's happening inside this field. That's a new challenge that we are facing today. Okay, it's to keep really the grower in the middle of the process and to help him really on these three different topics: see above, see further, and see closer. So
really, yes, really interesting because
yes.
Thank you for that, Eric, because actually you summarize also the point from FAO saying that the farmer has to be at the center place of smart agriculture. You highlight also some key technology that we have to provide them with, and it's really also a good introduction to the presentation from Régis Sablin, presenting some solution also ongoing. So that's really a very interesting point. We see the demand, we see the need for the farmer, but what could be the right business model towards smart agriculture, and do you think it will impact the current value chain in the agriculture field?
Yes, so what could be a right business model? In fact, the question for us today is to move parts of the add value to the grower. So in order to do that, you can, for example, reduce some part of the costs that you have, and it's what we are doing, for example, in ITK. We help the grower to use less pesticide or to use less water, to use less input. On doing that, you are increasing, in fact, the add value that the grower can keep for his own production, okay? But also, by doing that, you start to impact, in fact, the current value chain. For example, if you look at, I'm going back to Monsanto, Bayer Crop Science just made an offer and tried to buy Monsanto for $68 billion. Why? Not because Bayer is really so much interested by the genetic capability of Monsanto, because you understand the increase in production, in ag production, will not come mainly from genetics, but will come from, in fact, from changing the cultural practices. So Bayer is really interested to buy Monsanto. It's because Monsanto bought 3 years ago Climate Court, and Monsanto is today in this business the company we invest the most in fact in digital farming. Okay, so that explains why it's the bigger interest of Bayer for Monsanto is there. So by saying that, you understand immediately that smart agriculture is already impacting, in fact, the current value chain. If you lower, for example, the pesticide uses, or if you lower the water uses, okay, by nature, you impact, in fact, this value chain.
Really interesting. Could you give us maybe a few examples on what you are also doing at ITK you had also benefited from the Gateone-project, so that we could then further present that through, with a presentation from Regis. But could you give us a bit more information on the way you're working within ITK to support smart agriculture?
Yes, just quickly, I'm coming back to the presentation. Perhaps I will go to not to this slide, but so ITK is developing crop model and decision support system. But through the Gateone project, in fact, we developed, for example, this flow meter, this connected flow meter. So with, for example, with connected sensor that we develop here with Gateone, we are able to help the grower not to see his field as an overall system, but he can see inside his field the different zone and manage each different zone of his field. So by doing that, you are able, for example, to have a closer eyes on what's happened inside your field, but you can also, in fact, increase your crop production. Because today, fields are managed on a global way, okay, because there is no other way to do it except if you are using, for example, variable rate tools. But now with IoT, you can really go more closer to what's happened to the field, and you can even get the data that you need to simulate your system. And by simulating the system, you can have better, for example, better cultural practice, and you will increase, in fact, for example, your crop production or reduce your cost or lower, for example, your risk. It's what we are doing now, for example, and we launched this product. You cannot see it, but we launched this product this year with Verizon, for example, in the US on the vineyard, for vineyard management. Okay, that's one example of the activities that we developed by using the Gateone project. I don't know if I answer your question.
Yeah. So it's really interesting. Actually, it's very important also for us to understand how you are implementing smart agriculture. Your company was first active in developing some models, and now, if I understood correctly, you are using connected devices and smart sensors to facilitate the access to those models and to facilitate their use. Is that correct?
Yes, exactly. It's what we are doing.
Maybe you can give us a few examples. I think you have a...
Yes, I can show you, for example, the importance of that on the central role of model inside this process. For example, if you look, we receive, for example, aerial images from a satellite or from drone or from a plane flying. Okay, so we get data. We get also data from sensor. It can be a soil sensor, it can be a flow meter, it can be any type. We also receive the data, all the cultural practices. But just to show you an example of the central role of model inside this process, on this picture you can see that, for example, the max biomass in some zone is lower than normal. You don't know why. Okay, it can be linked to a plant loss. Okay, in this case you will have a huge yield impact. Okay, but it can be also just a phenological delay because you are taking this picture at this time. Okay, and for example, the LOI should be much higher on different zones, but it can be just linked to phenological delay. In this case, the yield impact will be really low. So you will not do the same thing linked to what the reason are linked to, in fact, this picture. Okay, and through the model, you will be able to really to tell what's happened really inside the field. A second example is here. So the model will answer this question. The second example here, on the spatial heterogeneity that you have here, are they linked to nutrition deficiency, for example? In this case, you will need to increase fertilization in some zone. So you will have to use, for example, variable rate application for that. Okay. Or does it link to soil water problem? In this case, perhaps you need to lower fertilization, but sensor will give you the information. They will tell you, okay, it's linked, for example, to nutrition deficiency, or it's linked to soil water problem. But without a model, you cannot calculate the yield impact, so you cannot decide. You cannot really adjust, in fact, your cultural practices to your need, even if, for example, in this case, the sensor will help you to answer part of the question.
Okay. Clear. Really interesting.
So just to finish on that, so for us, so augmented agriculture, in fact, at the core of augmented agriculture, you have the model. But you have the model, but not only the model. It should be a synergy between, in fact, all the innovative tools that we have access today, or the grower have access today, aerial images, sensor, weather predicted information through model and so on. And crop model will help you to integrate all this information together with the grower practices and the grower objective. And in this case, only the model can help you to do that, and you will really, now you will be able to have an augmented agriculture system, in fact.
Right. So yeah, it's not augmented reality. It's augmented agriculture. It's even more than reality,
yes.
actually.
Yes.
Thank you very much, Eric. Very, very interesting. And we are also very pleased to have you with us today, because you're also one of the first that has benefited from the Gateone-project. So thank you again for that. If you have questions for Eric Jalaz and questions of smart agriculture, please don't hesitate to ask them. This is the contact details also for people that can ask questions for ITK. Eric, is that correct?
Yes, it's they can contact directly Philippe Stoop, who is our director for research and innovation in ITK. You have his address, his email address, or his telephone number.
Perfect, but we will send that also to the participant. Thank you very much. Now we have seen that there is an interest, there is a market to be developed, because ITK is growing its market in addressing smart agriculture with an IoT solution. So I'd like to ask Régis Hamelin some questions and some advices on how to enter into smart agriculture through access to technologies. So Régis, what are the emerging solutions in smart agriculture, and how can we get some support maybe to enter into smart agriculture?
Okay, thank you, Geraldine. So yeah, so first let's talk about the solutions which are needed. We have the next slide. And thank you. So this is a slide which has been produced by the company Rabobank, and we can see here in this vision that we do not only talk about smart agriculture, but about a smarter full food system. So we have seen that we are talking about farm inputs. What are the information that we can collect from the fields? We also seen that farming and the drones can give us some information also. So we've just heard that the drones the picture can tell you where is the problem, and the sensors can tell you what is the problem. So there's some kind of fusion which is made, enabled by the models developed by companies like ITK. And we will see also that we can also work on the processing and on the distribution and retail of food. This is really from the farm to the fork. And also we have some running projects on the poultry houses that we're going to discuss. On the bottom line, so we're going also to discuss about this water management thanks to the project we've done with ITK. So all the top part of these slides are technologies that we have today in the portfolio of Gateone. All the bottom lines are more data processing, which are really out of the smart system area. This is really about big data, and those are not into our portfolio. So let's see how Gateone is working. So Gateone is an innovation action which is funded under Horizon 2020, And as the name of the project says, we start from an ID, which is the gate 0 into a new product introduction process. And our goal is really to work with an SME who is going to adopt the technologies that we want to develop and go from the ID to a business case and a demonstrator. You will see that in the next slides, we started really from concepts, ideas of products, which are really not products, and we want to push those technology to a real-life experiment. So our idea, our mission from the Commission is really to generate a partnership between a research organization and an SME to develop new products, and those products could deliver breakthrough or radical innovation. So what is our process? So we start from those ideas, and if one SME expresses interest into one technology, so we select one, we enter into a technical discussion between the research organization and the SME, and there's a time here where you have time to specify and adapt what you want to do. And in the parallel, in the same time, we must have a business discussion, because in Gate 1 we are really working like investors, and what we do is really manage the risk. We want to make a demonstrator that will release the risk, the technical risk, and with a small amount of money, we have investment which can range between 30 to 100 kilo euros. We will make a real-life experiment to give the opportunity to SMEs to test the technology and to check how mature it is for the market. Then once we have made the decision for investments, this is a decision which is made very quickly. We have a mandate from the Commission to take our own decisions. Then we go through a development phase between 6 to 9 months of the technological development. It can be shorter sometimes. And at the end we deliver the demonstrator to the company so that the company can have a hands-on experience on the technology. And this is free of charge. The company doesn't have to pay the research organization. This is funded by the Commission, and there's no obligation of the company to make any contract at the end of the project. So there's no ties attached to this offer.
And I think that today you will introduce us some technologies and we can select the one we are interested in. Is that correct?
Absolutely, yes. We have a selection. We have made a selection which are fully applicable to the agriculture domain. So you can see here on this slide the various partners, the competent centers who are involved into this project. And we have also, in fact, we are part of a larger organization which is Smart Anything Everywhere. And the Gateone-project is one of the 4 innovation actions which are currently funded by Horizon 2020. So one outcome of this project is a project that has been done between CELAT and ITK, and you can see here this this demonstrator, which was in fact installed into vineyards, and it is a flow sensor, and at the same time it measures the flow of water that goes into the field, then it generates the energy to send the information to the network. So it's a fully autonomous sensor. So we just heard about how this product will make its way on the market, thanks to Eric Gelas a few minutes ago. And this is exactly what we want to do. We really want to help companies to enter into smart systems. ITK is a company, is basically a software company, and they're in the process of acquiring some hardware technology based on smart system, and this is really part of the mission of Gateone. So how can we collect farm inputs? Here I'm going to introduce you 2 technologies which are still open for demonstrations. Those are sensors that you can put into the field. So we have understood that these are the sensors that will enable the understanding of what is happening into the field. So the sensors are based on 2 ion selective electrodes, which are electrochemical sensors. And those sensors you see, that you can see here, this is based on 2 PCB technology. So this is really cheap, disposable sensors. You can replace them very easily. And the idea here is really to go from this concept to a demonstration that would be done in the field. So the idea would be to use that either into water testing or even into smart agriculture and collect some information from nitrates into the soil, into the ground. So this is one technology which is today open for a demonstrator. Another technology which can also be applied for smart agriculture is a trace chemical and biosensor. This sensor has a specificity to give a 100 to 10,000 fold improvement in terms of sensitivity. And the volume of liquid which is necessary to do the test is extremely low. You can see here that the technology readiness level here is quite high. We consider that TRL to be at a level 6. And the vision is that it could be used in many different applications. It could be used either into veterinary
So we are losing you a bit.
applications to test. Okay, am I back?
Yes, the noise that's so good. So I hope you have good connection.
Okay, so the nanosensor that you can see here in the middle picture is the core technology, and what is available to them. So we are now looking for an SME who could be interested to test one of these application scenario, either into veterinary, food, or soil measurement. So on the farming, we have seen that drone.
Regis, maybe just we can ask one question to the participant now. What could be good is that if participants can ask us if they are interested in getting more information about those ionic and biosensor. So you have a few seconds to let us know if you are interested in them or not. So just 5 seconds more, and I think we're gonna go back to the different solutions that Gateone can offer.
Okay, so now for the farming, we saw that drones are really everywhere in many applications, and in fact we've seen that it helps to understand where are the problems. So in the portfolio of Gateone, if you could switch to the next slide, please, Geraldine.
Yes. So in this slide, you introduce us Hyperspectral.
I don't see the slide on hyperspectral imaging. I don't have the control of the screen. Okay, so here what we want to show is indeed that drones can help to locate the problems. So to date, you can maybe see in the marketplace some multispectral images which are sold for drones. Multispectral, it means that you will have access to 2 or 4 different images in 4 different wavelengths. Here we are talking hyperspectral imaging. It means that you will collect the whole spectrum with a very narrow bandwidth for each wavelength. So in the portfolio of the Gateone project, you have hyperspectral imaging, which have been used already for agriculture. You have here on the bottom left some examples of specification from 400 nanometer to almost 1 micron, and a 2 megapixel imager, and also some Earth observation which have been designed specifically for nanosatellites. So this is more advanced. This is not something that we can do in the frame of Gateone, but just to mention that hyperspectral imaging is accessible to people who would like to understand more about that. So maybe next question, Geraldine, for this opportunity.
So yes, we are interested to know if you could be interested in testing hyperspectral imaging. You have a few seconds to let us know if you're interested. I count 5, 4, 3, 2, 1, and then I give you back the floor. Thank you
Okay.
for the voting for the participants, and we can go back to the presentation.
Okay, so the next slide. So we're going to, we're going to talk very shortly about the Gateone project, which is running about the poultry house. So you see that again on the slide, the first slide which we showed on the smarter food system. Poultry is also one critical aspect, and one problem that we have tackled into the Gateone project is the monitoring of ammonia into poultry house. And in fact, we understand that the level of ammonia which is present into poultry house is so high that there's no sensor today available that can make there's no sensor that can last very long. They die after 3 to 6 months. So the objective is here really to push to have a long-standing sensor. And so the Teesside University is currently working with an SME to develop a completely different ammonia sensor that should withstand a duration of 1 year into this environment. So this is very important because if the ammonia concentration is higher than 30 ppm, so we know that birds are no more, they can develop diseases and they are not uniform. So the production itself is even worse, and the life of this poor chicken is not very good. So this is, again, one example of how the Gateone project can support innovation.
Okay,
so a few words.
Also the questions about interest in knowing more about this ammonia sensor. Just a few seconds.
We could be interested to have people to test those sensors in the field. We have one company currently which is developing it for commercialization. So the testing is still an open question.
So now we can go back to the introduction of solutions that are available within the Gateone project.
Yeah, for the food processing. We're going to see, next slide please. In the food processing, we need to check the maturity of. Geraldine, could you move to the next slide? It's a slow process. Okay. So here, what we suggest for the food, for testing the food, is to use a spectroscope. So a spectroscope is kind of complex system, but the idea here is to make it so small and so simple that it could be integrated at the end into a handheld device. So this handheld device could be a smartphone, and this smartphone could simply collect spectral information from whatever you're looking at, and with a combination, with a fusion of the image and the spectrum, then you could maybe identify the food, collect some nutrition facts, and have more information of maybe presence of allergens or these kind of issues. You can see here how this tool can be used for fruit ripeness measurement, so the maturity of tomatoes or the ripeness of pears here. Another example of application is here again in food, is for the control of oil. Here we have a number of samples where there's a mix between olive oil and sunflower oil, and you can see here that this experiment helped to understand where we were standing in terms of a mix between the both. So this is again some technology which is available, and for the packaging of food, we also have into the portfolio another technology which is open for demonstrator, which are indicators for volatile aldehydes, ketones, and sulfuric compounds. Those indicators can be printed onto a number of flexible substrates, and some demonstrations have been done onto poultry and salmon, quality of salmon. So the signal that you will receive can be either visual. You can see here an example of how a cross can appear into the package, or you can see here a detection of leak for one particular package. If some oxygen enters into the package, then you will have this blue color and with a printed message. So it can be a very simple message, but it can be also a more an electrical signal sent through an RFID label. So again, this is some technologies that we could offer for test to an SME. So we can maybe launch the questionnaire.
So would you be interested in solution for fresh product monitoring? Yes or no? And I think, and if you are interested, which is the case for people participating to this webinar, then please indicate us which one could be interested to you. It could be the food processing or the food packaging. Okay, so just 2 seconds, and we can close this these questions and go back to the presentation from Regis.
Yes, for the last technology or last idea that we would like to suggest, we are talking about indoor farming. This is something really new, and the idea is really to use UV lights to grow plants. And for that, we would like to introduce you to one particular technology, which is about material technology. It's a metallic cluster that can be so I'm waiting for the slide again. It takes a little bit of time to refresh the screen. So yeah, so this is this particular material, this metallic compound that can, when you excite this compound with UV light, then it emits into the deep red spectrum. So this is a metallic cluster that can be embedded into plastics. Plastic packaging. And why is it important? What could be what it could be of interest for indoor farming is because chlorophyll is of course sensitive to UV, but it is also sensitive to the deep red spectrum. So if you're using UV LEDs and that you include those clusters into the packaging of these UV LEDs, you could have a better yield into the growth of the plants, because you will excite both regions of the chlorophyll, both A and B. So this is one additional solution that we suggest for one particular application, which is something really innovative in itself, the indoor farming.
Right, so maybe we can have the questions to the participants if they could be interested in indoor farming. So just a few seconds to answer the questions. And I think we're done with this question. So, Regis, you are available for contact details, correct? If people has to ask you questions.
Yes, sure, of course. If anyone is interested to one of these technologies or maybe other technologies that we did not share during this meeting, you have my contact details and you can contact me anytime, and we will contact you back shortly to organize the technical discussion with the partners.
Thank you very much. So now I'd like to have the questions to the participants. We are very interested to know if, according to you, after this webinar, do you consider small agriculture as an interesting market for you or just more globally? We are very interested in your feedback. It's also very interesting for us because it's also a message that we can give back also to the European Commission to show that there is interest for companies in Europe to further invest and innovate in agriculture. So this is an important point to us. And thank you for answering. And just for you to know is that all the participants consider that smart agriculture is definitely a very interesting market. So that's very good news also for us because it means that we are working on a bankable challenge, which is really good. And also to finish this webinar, we would like to know if you would like to receive more information on the Gateone-project or on ITK, but also on FAO activity and more globally on smart agriculture, because we will be very pleased to provide you with more information, and the speakers of today will be available also to answer your questions. So if you wish to receive more information, please don't hesitate to let us know. So thank you very much for your participation to the webinar. Some of you has directly questions to RTK and to FAO, so they will answer you directly by email. Don't hesitate also to ask your questions or requirements to Régis Hamelin. You see the contacts now on the screen. If I succeed, yeah. And so thank you again for your active participation to this webinar. We hope that it was an interesting webinar for you. And we will keep you informed about the next webinar on Gateone activity, which will be dedicated to highlight the success story of the project. So you can also further have access to it and benefit from it. Thank you very much, Régis, for this very interesting presentation. And thank you to Nevana and to Eric, who had to leave already the webinar. But thank you all and have a very good afternoon.
Thank you. Bye-bye.
Bye-bye. Thank you.
Eric, you're still here. Yes, so thank you very much.
Yes, I
Eric.
was still here. I sent you some message.
Thank you very much, Eric. Very good to have you with us. Thank you all.
Thank you.
Have a good afternoon.
Bye-bye.
Bye.
You too. Bye.